All right, guys, so we're starting chapter 8. I know we just went from 5, is the chapter we just finished. Chapter 6 is all about exponents and like different roots. So like cubed roots, fourth roots, fifth roots, all that stuff. So there's no factoring involved in it. Chapter 7 is logarithms, which is how to solve for exponents. That log button on your calculator you probably looked at and been like, I don't know what the heck that is. We'll learn about that. But we're going to jump to chapter 8 because factoring should be fresh in your mind right now, and there's a lot of factoring in that chapter 8. So we're going to jump there while factoring is fresh because you don't need factoring in 6 or 7. In chapter 8, notice this is 8.4. We're only going to do 3 sections, 8.4, 8.5, 8.6. Okay, I'm trying to hit what I can. I only have you guys for one more semester. So I'm trying to get as many of the important things to you as possible. What? What did you say? Yeah, you're right. You're right. I have you all second semester. So yeah, fourth quarter. You're right. You're right, fourth quarter. So in this section, or this chapter, we're going to look at fractions that require factoring in them. So we're going to start out by simplifying, then we're going to do multiplying and dividing, adding and subtracting, and then finally solving. Now, I know you guys in your fraction phobia, right? You guys panic with real numbers, let alone if I throw rational expressions at you, x's and everything else. So the purple sheet, you will be allowed to use that on your test. You can only write your name on it. If you write other stuff on it, I'm not going to let you use it. So don't lose it, okay? Cherish it. It is your lifeline. And do me a favor, please read it. You wouldn't think I'd have to say that, right? Read it. I can't tell you how many times somebody will raise their hand, I'll walk over to them, they're like, I don't know how to do this. And I will literally read for them their purple sheet, and they'll be like, oh, thank you so much, I get it now. I'm like, all I did was read your paper, I didn't do anything. Okay, so read it, okay? If you get lost, read it. You're right, I did get paid to read it for you. But anyway, so we're going to start to, we'll spend 2 days on each section. So this section has simplifying, multiplying, and dividing. So we're going to look at just simplifying and multiplying today. It's not because dividing is that much harder. It's just I don't want to throw too much at you too fast. So we'll just do simplifying and multiplying today. All right, but first of all, you need to know what a rational expression is. So rational just means fraction, ratio, think about fractions. But we're throwing a whole lot of algebraic stuff in here, right? So here's an example of one. It's got just a monomial on top. There's a binomial on the bottom. This one has a binomial on top, a trinomial on the bottom. That one's got a trinomial, and then it's just got a plain old number on the bottom. So these things can look in different forms, but you're going to have x's in there. You may have some y's in there, and you're going to have to try to simplify these things, or eventually next week we'll be solving. We are not solving this week. Okay? So in a simplified rational expression, the numerator and denominator have no common factors other than 1 or -1. So in other words, you wouldn't give me 10 over 15, I hope, right? You would simplify that as a fraction. We're going to start by simplifying. So if I look at AC over BC, does anything need simplified? Yeah, it's got C's on top and bottom, right? So we could cancel those and it would just be A over B. So we're going to be working on how do you simplify with all of these X's and everything involved. Okay? So let me show you we have a simplified version versus the non-simplified version of the same problem. So if I look at this, here's my original problem. Here's what the simplified version is. What did they cancel out? The x minus 2's. The entire piece canceled out, and all they were left with is x plus 3 over x minus 3. What about those x's? Why couldn't I cancel those out? Or how about the 3's? The plus and minus stuff. That's huge, and that's honestly the biggest mistake that students make is they're like, oh, x's, I'll cancel those. Oh, look, there's 3's, I'll cancel that. So what's your answer? Plus over minus? Doesn't make any sense. Okay, anything that's held with a plus or minus sign, that's like considered a group. And sometimes it's helpful to throw parentheses around the outsides of it because you visually see it as a group, a whole piece. Okay, so I need you to make sure you guys are clear. If it is held, so if it is held together with a plus or minus sign, you cannot cancel its pieces. All right, so if you see a plus or minus holding something together, it's either you cancel that entire group out or you don't touch it. Or you can factor it, but I mean, you can't just like cancel piece by piece out of there. So like if you look at the next one, x squared plus 4x plus 3 over x squared plus 4x plus 3, this stuff's held as the group, right? Because it's held with either a plus or minus sign. But are they exactly the same on top and bottom? Yeah, so I can cancel the entire group with the entire group. Why is the answer 1 and not 0? What if I gave you 5 over 5? What would you tell me that is? It's 1, right? 5 divided by 5 is 1. But I wouldn't cancel that and tell me it's 0. Right? It's the same idea. You're dividing them, it's still going to be a 1, not 0. And then down here, 4x squared over 8x. 4x squared over 8x. So I look at that one. Is there any plus or minuses holding it together? No. That means I can piece this thing out one piece at a time. So there's an x on bottom and there's 2 of them on top, so I can cancel this one. This will just be x to the first. And then 4 and 8 can both be divided by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So on the top I have 1x, and on the bottom I just have a 2. But there was no plus or minuses holding that stuff together, so you can take one piece at a time and kind of piece it out. And we'll get lots of practice with this today, okay? All right. The next part we're going to talk about is restrictions. Again, this is me having the foresight, knowing what's coming, so I'm trying to like prepare you for what's coming up next week when we get into solving, okay? If you practice it now, it becomes second nature by next week. So a rational expression in its simplified form must have the same domain in order to be equivalent. All that means is when I'm looking at my restrictions, you want to look at the original problem, not after you've canceled it, okay? So the domain will include all real numbers except for numbers that make the denominator equal what? When you think of fractions, what can you not divide by? 0. So you have to, we're going to get practice on looking at, if I have a 0 in the bottom of my fraction, those are restrictions. When we get into solving, those become our extraneous solutions, answers that are no good, okay? So numbers that make the denominator equal 0 can be referred to as restrictions. So for example, let's go back to one of the problems we just looked at. So this problem, this was the original form of it. The denominator is where I can't have a 0. Can I have a 0 on top? Yeah, 0 divided by anything is just 0. So that's okay. But on the bottom, I cannot have a 0. So if I would set each of these equal to 0 and solve, which you guys have done countless times in the last chapter, what does x equal here? And 2. So in other words, those are my restrictions. Because if x would equal 3, and you'd plug that back in, 3 minus 3 is 0, that puts a 0 in the denominator. I can't do that. If I plug in a 2, 2 minus 2 is 0, puts a 0 in the denominator. I can't do that. Okay, so in other words, to find your restrictions, to find restrictions, set the denominator equal to 0 and solve. So if you look at that other example over there, 4x squared over 8x, again, it's the original problem. What would x equal here? 0. That's like your baby brother out in front, that x. Remember, it's always x equals 0. So x is not allowed to equal 0. That'd be a restriction. I'd put a 0 in the bottom of my fraction, which is no good. You guys ever ask Siri what 0 divided by 0 is? No. Hold on. What is 0 divided by 0?
Imagine that you have 0 cookies and you split them evenly among 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies, and you are sad that you have no friends.
So sad. So, can't divide by 0 because you have no friends and it's very sad. Isn't that great? All right, so the purple sheet, Notice it's kind of separated in separate columns there. Your purple sheet, which is your lifeline to this chapter, please read it. First of all, you need to recognize which column of steps that you will be on. So we're going to start with one fraction. You're just simplifying a single fraction. That's where we're going to start today. And then the next column over says multiplying. We'll also look at that one today. So you have to kind of look at what problem you're doing to know which column to look at on your purple sheet. Okay? So your steps, though, are on here step by step. Please do them in the right order, otherwise it's going to be wrong. Step one is you're going to factor, if you can. Then you'll do your restrictions, looking at the denominator, right? Restrictions come from the denominator. Just make sure we remember that. And then we'll cancel anything we can to simplify. Okay? So number one just says simplify the expression, state any restrictions on the variable. Amanda, put it away, please. So first thing is, step one on your purple sheet says to factor. Can you factor either the top or the bottom? If it's just one term, can you factor one term? Think of your factoring flowchart. It's broken down to 2 terms, 3 terms, or 4 terms. Does it ever say 1 term on it? No. So if it's only 1 term, I can't factor that. Step 2 is my restrictions. So looking at the denominator, what can x not equal down here? 0. Do I need to list 0 5 times? No. You're telling me what it is not allowed to equal. You can write x cannot equal 0 5 times if you really want. That's kind of overkill, but not wrong, but not necessary. Bree? The restriction? Yeah. I'm just setting this equal to 0 and solving. So think back to last chapter. If your baby brother out front said 20x to the 5th as your baby brother, x would be 0 as an answer. Because think about, if I plug 0 back in here, what's 0 to the 5th? Times 20? 0.
Is that going to be the whole, like, every time?
It's not always 0. Depends on the problem. And we'll look at a lot of examples. It'll get better as we go. All right, and then your last step is to cancel. Now, is there any plus or minuses holding stuff together as a group? No, so I can piece this out, right? So I can cancel out 2 x's on top, right, the x squared. How many would be left on bottom? 3. And then 15 and 20 can both be divided by 5. 15 divided by 5 is 3. 20 divided by 5 is 4. And what do you got left? Please rewrite. Don't make me look through all your chicken scratch. What do you got left on there? 3 on the top and 4x to the 3rd on the bottom. And that is as simplified as it can be. Doing okay? Think so. All right, take a look at number 2. Step 1 says to factor. Can you factor any of that? If you don't have a plus or minus sign, you're not factoring. Okay? Because they're all just 1 term, so I can't really factor. Restrictions. X cannot equal what? 0. There's a y up there. Y cannot equal 0. Again, think about, that's kind of like just that baby brother that you've pulled out in front, which gives you that 0. All right, so those are my restrictions. All right, so is there plus and minuses holding stuff together? No, which means I can piece this thing out, 1 piece at a time. So what do you want to cancel? The -6? I can divide them both by -6. 24 divided by -6 is -4. -6 divided by -6 is 1. How many x's can I cancel? 2, because there's 2 down here. How many would be left on top? Just 1. How many y's? Good. I can cancel 2, which would leave me only 1 on the bottom. All right, so let's rewrite. What do you have left on top? And on the bottom? Just y, 1 y. You don't have to write the 1 though. Now, what's honestly going to happen with many of you is you're going to cancel things beautifully and perfectly, and you'll go to write your answer. You'll forget something. It happens all the time. I do it still. Because you've like crossed this off and crossed that off and moved stuff and everything, and then you're like, you write your final answer, I go to grade it, and I'm like, what about that? Like, I'll circle it. Like, it's up in your work, but you just didn't see it when you wrote it down. So just be careful. Watch your how messy you are when you're canceling stuff out. Watch your handwriting. Right, number 3. Step 1 says to factor. Can you factor that one? Yeah, we can factor that. So let's factor the top. Yeah, factoring. Lots of factoring. Those of you that are good at factoring and pretty quick at it, you won't mind this chapter a bit. Those of you who are really slow and not so good, you will hate this chapter. So how does that top factor? X plus 4 and x minus 2. Bottom? Be careful with the bottom. That's that dreaded 6-5 combo. Because your options for C is either 1 and 6 or 2 and 3, which both can give you a 5. But you got to watch your signs. So what do you think on the bottom? What? Good. It's got to be x minus 3 and x minus 2. Since your last one's positive, both of your signs have to be negative, which means you can't go 6 minus 1, because that would be 1 plus 1 minus. All right, what's step 2? No, read your purple sheet. Restrictions. See what I mean about reading that thing? People don't read it. It's right in front of you. I don't get it. I even used a nice font that was easy to read. All right, what can x not equal? 2 and 3? So do you see there's an example where 0 is not one of my restrictions, right? Set this equal to 0 and solve. Set this equal to 0 and solve. It's always the denominators, because my denominators are not allowed to equal 0. So you set them equal to 0, and you solve them. Right. So since that would what they would equal, therefore those are my restrictions, and it cannot equal that. Or it would put a 0 in the denominator, and you'd be sad because you have no friends. All right, what cancels? The x minus 2's. So I have x plus 4 and an x minus 3. Can I cancel those x's? Why not? Good. They're held with a plus or a minus, which makes them a group. And I really think it helps if you see those parentheses around there. You're more apt to be like, oh, that's a group. I can't take part of that. Okay, that usually helps. Restrictions. And there we go. When it comes time for your test on this, I'll actually have a line that says restrictions, and I'll so you can list them. That way it's easier. Okay, number 4. Step 1. Step 1, read the purple sheet. It says factor. No, I'm not going to read it for you. I don't get paid enough to read it for you. All right, how does the top factor? Thank you. X plus 4, x plus 1. How about the bottom? Thank you. Those are my favorites. X plus 4, x minus 4. Difference of squares. So that was step 1, factoring. Step 2, restrictions. What can x not equal? Good. Plus or minus 4. I'm lazy. You can write them separate if you want. I like to write them together because I'm lazy. It's true. All right. So that was my restrictions, right? That's just from setting the denominators equal to 0. And then does anything cancel? X plus 4. So I have x plus 1 over x minus 4. Can I cancel the x's? No, I cannot. And again, if you want to see those in parentheses as a group, you can do that. Not necessary, but you can have them like that. Take a look at number 5. Does that bother anybody? What bothers you about it? A lot. Specifically, what bothers you? The order. That's what I was looking for. Guys, you need to make sure everything is written in standard form. So that should be negative 4x plus 12. The negative still stayed with the 4x. The 12 is still positive. But please make sure you're rewriting everything in standard form. The x should come before the plain numbers. Eli, you okay? All right, what's step 1? Factor. How do I factor the top? Thank you. My A block, they just stared at me. No one came up with take out a GCF. I'm like, seriously? The first thing you ever learn about factoring? But good. What is my GCF? Thank you. Negative 4. So if you take out a negative 4, what's left over? X minus 3. Thank you for the sign change there. The bottom? Good. My favorite. All right, so that was step 1, I factored. Step 2, restrictions. What are my restrictions? Good. Plus or minus 3? Anything cancel? X minus 3s. So left over on top, we have a negative 4. On the bottom, x plus 3. And I'm good. How we feeling? Good? Hungry? What don't you understand?
Will this help us with anything?
Yeah.
No, I mean in that. Will this help us solve something?
Yes. Yeah. We'll be solving next week. In your real life, many of you will never use this. Let's be real honest. I'll be honest with you. We got a test next week. You need to pass that. You got to pass my class to graduate. There you go. Big picture. I'll be honest with you. Most of you, no, you won't need this.
Why do you like that so much?
It's fun. Thank you. Oh man, when you get these big monstrous problems and you're like cancel, 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 and you're like, yes, like it's fun. You guys are sad. I don't know how you don't understand it's fun.
Yeah, right. You need something more fun.
It's terrible. All right, number 6. What about number 6? What do you want to do first?
Combine like
Say that again?
combine like terms of the combination.
No one in my last class caught that. Very nice. Very nice. Look at the bottom. You got like terms sitting there. Yeah, you got a 15x squared plus 9x. Very nice, Jordan. Good catch. Let's be honest. Did anybody else catch that?
I did at the very end of the problem.
Very nice. All right, so step 1 says to factor. The top. Good. 3x squared. From the top? Oh, yeah. Yeah, I'm taking one out. I'm taking out 3x squared. So we're left with 3x plus 2. Yep, your GC. What's wrong? She's got that look. Okay. Good. And you can take out a 3x from the bottom. Good. 5x plus 3. All right, so that was step 1. We factored. Step 2. Restrictions. X cannot equal what? 0 and perfect.
So you said it equals 0. Solid.
Yep. Those are your restrictions. 3's okay. Baby brother, if you pulled out a 3, did it matter? Was he an answer? No, just the X's. I know. See, take everything back to baby brother. We're like, oh yeah. All right, what cancels, guys? I'm going to go real quick. Can I piece out the 3x and the 3x squared up here? Are they held with plus or minus?
I was like, why?
They're not held with plus or minus. I can piece those out. So like the 3 and the 3s, I can cancel those. I can cancel this x. There should just be one x left on top. Anything else? No? Can I piece these out? Can I cancel this 3 with this 3? Are these held with plus and minus signs? Can't touch those. You either take the whole group or not any of it. That's it. So on the top we have an x and a 3x plus 2. On the bottom we have a 5x plus 3. Yes. Mm-hmm. Say that one more time. Wait, you're talking about this right here? Mm-hmm. Oh, no. You can factor stuff out, but you were trying to do the canceling right there. And they're held with plus or minus signs, so I can't. Good question. All right, we ready to move into multiplying? Which is really just like a one step beyond this.
I like this.
Smoosh. It's my favorite term. Very mathematical right there. So what's the difference in your steps? Smoosh. The only difference is at the bottom. That's fun to say. Very mathematical. Smoosh. Smoosh. Technically, if you look in any math textbook, they're going to tell you to multiply. I don't necessarily want you to multiply because your answers need to be in factored form. So I don't want you to actually like distribute back into a parenthesis. I don't want you to FOIL. Okay? Don't do that. Now granted, if I have like a 2 on one and a 5 on the other, please multiply that and make it 10. And we'll look at something like that. But I want your answers in factored form with the parentheses. Okay? All right, real quick, let's take you back to like 3rd grade, 4th grade. I don't know, I can't tell. If I gave you 18 over 25, and I wanted you to multiply that by 30 over 90. And I said, do not use a calculator. What do you mean by cross? Like X's? Way wrong. Every single one of you, way, way wrong. Cross multiplying is when there's an equal sign in between there and you're solving proportions. To multiply fractions, it's straight across. Straight line. Top times top, bottom times bottom. However, what if I told you no calculator? Would you cry?
Yeah, I do lattice.
10. Oh. Lattice. I think it's the waste of time I've ever heard. Alyssa? Yes, thank you. Alyssa's got a great background in math. Thank you very much, Alyssa. Simplify first.
Oh, that would be smart.
Right? That would be smart. You can simplify, guys, you can simplify fractions any top with any bottom. Any top, any bottom. I don't care if they're right on top of each other. I don't care if they're kitty corner from each other. Any top, any bottom, you can simplify. So, I can divide, which one simplify? 30 and 90 both be divided by 30. So 30 divided by 30 is 1. 90 divided by 30 is 3. And I could divide 18 and 3. Can both be divided by 3. Any top, any bottom, right? So 3 divided by 3 is 1. 18 divided by 3 is 6. Any top, any bottom, I can simplify. I'm simplifying. We took 30 and 90. We divided them both by 30 to simplify. And then I'm like, okay, 18, and there was a 3 here, can both be divided by 3. Any top, any bottom. Doesn't matter if it's in the same fraction or not. Because I had a 3 here, and I had an 18 here. I could divide them both by 3 to simplify. So 18 divided by 3 was 6. 3 divided by 3 is 1. So what do you got left? 6 times 1 is 6. 25 times 1 is 25. Simplified. I don't need a calculator to do big old numbers. Yeah. No, you can use one. Hey, guys. This is like 3rd or 4th grade. I bring this up. I know, we stink at fractions. Wait till I get to adding, subtracting. You guys' heads are going to explode. All right? But until then, let's deal with multiplying and dividing. Because fractions and multiplying and dividing is way easier. All right, so when we're looking at this, the whole idea, if you guys are freaking out, don't panic on me yet. Any top, any bottom, I can simplify. Then I'll multiply or smoosh it all back together. Smoosh. Say it, it's fun. Okay? So, let's look at number 1. Now, on your purple sheet, you have to know which column you're on. I know this should be obvious, but what symbol does that little dot represent? Multiply. You laugh. I guarantee there will be a problem. Somebody will put a plus sign there instead. Like half my class did it on A block today on one of the problems. So just throw that out there. That's a multiply sign. Make sure it's multiplying. All right, so look at your column on your purple sheet under multiply. What's step 1? Factor, okay? Can I factor the top? Yes, I can. Does anybody know how the top factors? Good. X plus 3, x minus 2. Can I factor the bottom? No, that's just going to be a 2x squared. Can I factor the top? Take out a 2. So I have x plus 4. The bottom? Does anybody know how that factors? Good. X plus 4, x plus 3. So you go through the entire problem and you factor everything that you can. Okay? All right, what's step 2? Restrictions. So x cannot equal 0. Good. -4, -3. Next week, we'll actually get into problems that you're solving with an equal sign. These don't have equal signs, so you can't solve them. But once we get into solving, if you would go all the way through and be like, all right, x equals -3. No, it doesn't. That's one of your restrictions. That would be what's called an extraneous solution. So I'm trying to get you to that point for next week.
When we solve with equal signs, whenever we do that, is it going to be a lot harder than this?
Maybe. Depends how good you are at finding common denominators. We'll talk about that later. Well, yeah, let's not. We'll worry about that. We'll start Wednesday worrying about that. All right. So our next step after restrictions is what? Jenna, you with me? Somebody wake Jenna up back there. All right. What's after restrictions? Cancel. Any top, any bottom. What cancels? X plus 3's. X plus 4. Any top, any bottom. And then 2. All right, so what's on top? What do you got left? X minus 2. On the bottom, x squared. Can I cancel these x's? No, this one's held with the minus sign. I can't touch it. So there we go. X minus 2 over x squared.
This is so fun.
I think it is. Oh, making up my own rules. Whoever invented math. Really, math is more of a, not invention as much as it is a discovery. I don't know. To be honest, I have no idea what mathematician this came from. Yeah.
So someone could still be discovering stuff.
Oh, absolutely. They still are. Yeah. Okay. Number 2. Notice it's a multiplication problem. So look at your purple sheet. Step 1 says to factor. Thank you. You can read. Happy. Yeah. You're one of few, I'm telling you. So how does the top factor? We are finally recognizing difference of squares. I'm so proud of you. On the bottom, that's just an x. On the top, just a 3x. And on the bottom, how's that factor? Yep. 6. 6 is your GCF. 6. So then we have x plus 3. Okay, so step 1, factor absolutely everything that you can. Step 2, restrictions. X is not allowed to equal what? 0 and -3. Does that 6 on the bottom give me a restriction? No. Doesn't have an x with it. Baby brother that doesn't have an x, don't care about him. Step 3. Step 3 is to cancel. That's the fun part. What cancels? X plus 3. The x's. And 3 and 6. Divide them both by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. All right, what you got left on top? X minus 3 over 2. For whatever reason, my morning class told me they thought this was easier than just simplifying a single fraction. I'm not really sure why. It's because there's more to cancel.
Yeah.
It's fun. More disappears. And there is. See, it's fun, isn't it? A little bit. See? A little bit. All right. Make sure you're on the first floor. I don't want you to get hurt. All right, number 3. Step 1 says to factor. How do you factor the top part? Take out a 2. Good. So we have x minus 4. How do you factor the bottom? I got real worried. You guys were quiet for a second. I just praised you for that one. Okay, how about top of the other side? X plus 4 and x plus 1. That's what you meant, right? Totally. She was trying to do it on the fly. It's okay. And the bottom? Good. X plus 4 and x plus 4. It does sometimes. You're like, oh, yeah. All right. What's step 2? Restriction. Read that purple paper. X cannot equal plus or minus 4. Is 0 a restriction? No. There's no baby brother of x sitting up there, so there's no 0. All right, step 3, fun part, cancel. What cancels? Now be very careful on your x plus 4s. Okay? I can cancel this top one with either this one, or this one. Does it matter?
Yes.
Doesn't matter. I'm going to go with that one, just for fun. Any top, any bottom. Can I cancel these x plus 4s? Do they have something on top to cancel with them? It's got to be one on top, one on bottom. These are both on the bottom. They don't cancel. Yeah, it's got to be one top, one bottom. They got to be pairs that cancel. It's got to be a pair, top, bottom, that cancels. So, x minus 4s will cancel them. Okay, so here we go. Here's our smoosh step, right? On the top, what do you got? I have a 2 and an x plus 1. I did not say multiply because I don't want you to distribute this. Your answer needs to be in factored form. And on the bottom, you have x plus 4, or x plus 4 squared because I'm lazy. Either way. No. Don't use that word either.
Are you having a heart attack?
Yes. He said the F word.
There.
This video will be fun to listen back to, right? All right, so how we feeling? Okay? I don't want to hear tired, hungry. I got that. Math-wise. No. I know. We're almost out of time, though. All right. Bypass number 4 for sake of time. Let's take a look at number 5. Isn't he cute? All right, number 5, right away, notice that you don't have 2 fractions. Can I make it a fraction? Put it over 1. Yeah, over 1. Anything else bother you with this? The order. Yeah, it's not in the right order. So let's write this the right way. So it would be negative 10x plus 15. Make sure you keep the negative sign with which one is negative, okay? All right, so step 1. Factor. Can I factor a 4? No. All right, on the bottom. Uh-oh. Do I have to put a little more thought and effort into factoring that?
Slightly, but it's not.
Slightly, right? You got options for A now? So options for A, 2x and x. What are your signs? Plus, minus? And then C is 1 and 3? You got 1 and 3 or 3 and 1? 3 and 1? Did that work? You guys remember how to check? My signs are backwards. Yeah. It's 2x minus 3. And x plus 1. Okay, factor the top of the other one. You got what? Just 5? Negative 5. There it is. You're like, wait a minute, I swear there's nothing else in there. Yeah, that first one's negative. We got to take it out. So we're left with 2x minus 3. Yeah, that's next. I just needed to finish factoring first. All right, so step 1, factoring, complete. Step 2, restrictions. X cannot equal 3/2 or -1. Does the 1 at the bottom give me a restriction? No. There's no X there, so I don't care. Next step, cancel. Anything cancel out of that? 2x minus 3? All right. That's about it. So, on the top, hey Eli, what's that dot mean? It means multiply. 4 times -5 is -20 over x plus 1. So while I don't want you to distribute all your stuff together, if you have just two numbers like that, the 4 and the -5, please multiply those together. Okay, makes sense? And make sure it's multiply. I'm going to pick on Eli here, but he added them. Again. He's not going to be the only one. Somebody else will do it at some point. I guarantee it. All right, last problem on your own. All right, so step 1 is to factor. And again, that would be over 1. Make sure you know where. That way you remember that it's on the top of your fraction, not the bottom. So I can pull out a GCF of 3x. Leaves me with x plus 1 over 1. Pull out a GCF of 2. So we're left with 3x plus 1. The bottom, that will factor. What's that? 3x plus 1 and x plus 1. Okay, so that's factoring. Step 2, restrictions. X cannot equal -1/3 and -1. Good. Those are my restrictions. Cancel. I have an x plus 1. I got a 3x plus 1. All I have left is 3x and 2. Jordan?
So they have to be the same sign in order to cancel.
Yes.
Oh.
They have to be exactly the same. Yep. I saw some people tell me this was 3x plus 2. Where'd the plus sign come from? What's this? It's multiply. What's 3x times 2? That is 6x. That's 6x. Okay? Don't add your own plus signs in there because you thought they looked good. Okay? Read what signs in between there.